One big question, just a couple for the sake of time. One is, what's your allocation policy? Do you have an allocation board at the national scale, or do people pay for resources? How do you allocate the resources to individual groups right now?
Yeah, it's very interesting. So in the past, traditionally, we would have been very involved in the allocation ourselves. With this, because the system was funded more directly by the government, I think because it's at a scale we've not done in the UK before, it bypasses lots of the sort of previous schemes that have been in place, going through our research councils, things like that. So the two big routes I was talking about, the AI Security Institute and the Sovereign AI, are actually organizations inside the government directly. So they're within the Department for Science, Innovation and Technology, so DSIT. And people who want time on the machine write their proposals and submit them to them, not to the research councils. And they're doing the sort of really big allocations. Some of the admin gets outsourced to the research councils, but a lot of the decision-making, a lot of the direction setting is being quite strongly influenced and controlled by the government in a way that we've not had before. But I think they're saying, well, we're spending £200 million of our money. We want to have more direct say in what it actually gets to do. So our team is we're not making the decisions about what's being allocated.
And the second question is, so do you have a different, in terms of people running jobs, you said a lot are interactive, but also for these bad jobs, do you have, do you do something special? For example, we get a lot of requests from AI people that they should, the wall time limits should be much longer because right now, like Fugaku is 24 hours. Mm-hmm. People training Fugaku, they say, well, they want longer. Of course, we tell them to checkpoint and all that stuff. But do you have any more specialized job running policies to not just wall time, but anything you do special to that's less conventional in the HPC space?
Yeah. So I think because we're still in the first few months, all of that is still evolving. We're still getting a lot of questions from users saying, actually, could we please do this thing that currently your policies don't allow, longer jobs or bigger jobs or whatever it might be. So I think we've started off with something that's a reasonable first attempt, but we're getting lots of people bumping into restrictions that are stopping them from doing what they really want. But it's very easy for us if they submit a ticket and say, actually, this is stopping me from doing what I really like to do, and we're working with them. And so right now, yes, things are still changing. We're still adapting to how people actually want to use the system for AI. We've got a few months of experience, and that's it. So yeah, I imagine if we look back at our policies in a year or so, it will have changed quite a lot.
Dan.
Hey, Simon. Over here.
Yeah. Hi.
Same sort of operational question. So you mentioned, and I'm not surprised, most of your AI users are running from a container. It's probably an NVIDIA GPU cloud container to start with some mods. Has the interplay between containers and Slingshot caused any problems?
Yeah. So one of the things that actually slowed us down from already running Kubernetes is Kubernetes with Slingshot is a different kind of beast. It's kind of new. But HP's actually been doing a really good job working with us on that, and they've put lots of effort in, and there's been lots of good progress there. We're actually running our own event in March called the Isambard Summit. It's a 2-day event in Bristol. We've got 250 people coming, and HP are running a workshop on the latest status on where Kubernetes is with Slingshot and containers and all that sort of stuff. So there has been some work we've had to do. A lot of that now works. Didn't all work right at the beginning, but a lot of it now works. We're not quite there with 100%, but it's getting there. And the handy thing is it's not just us. There's lots of other big HP sites around the world who also want the same thing to work. So CSCS in Switzerland and the big US labs all got the same incentive. So it's getting there.
Yeah, the stack is sort of infinite.
I have a question out of curiosity. Do you see, you are a facilities manager in one way or other, but Do you see or already have a role in creating new ecosystems? Let's say that there is a cluster of projects coming from either government or local council or academics, and suddenly you say, hey, I can put something together here and start to foster and go outside proactively to chase new kind of things. So do you have a mandate on that?
Mandate might be too strong a word, but when we've got 50 megawatts of power, what's going to be the best way of using and deploying all of that? It doesn't have to be one big. In fact, I think it's unlikely it'll be one big government system. It'll probably be multiple smaller systems, but where a smaller system could be 10, 20 megawatts. But that could be public-private partnership. There are lots of interesting companies that university partners within the region. It's a big aerospace region, so we have a big Rolls-Royce site, there's a big Airbus site, GKN, et cetera, all who do lots of computing and all who are very restricted on wherever their offices are in terms of power and space. So we could potentially deploy modular data centers for partners with 1 or 2 megawatts, 5 megawatts, half a megawatt. So we've got a certain amount of space, lots of power. What's the best way of putting that to good use?
Because the entrepreneur on me see you as a founder of an incubator.
Yeah, and we have the people, right? So we've got the people with the right skills there as well. So I'm not quite sure how all of that will play out, but it'll be interesting.
Shane?
The R word, renewables. So 50 megawatts is quite a lot of juice. You're building these modular data centers. Are you putting batteries anywhere near? Are you putting solar?
Good question. So in the UK is actually pretty good in terms of renewables and improving. And in fact, we might get our own 8 megawatts worth of wind turbines right next door that will sell all their power to us for the existing system. That would give us about half the energy needs for the existing systems. So we pay a little bit more in the UK for Isambard so that all our power is local renewable. So it's only wind, solar, hydro, and battery. We don't even have nuclear in there and no bio or anything like that. We actually do better than the rest of the university. The other benefit is the direct liquid cooling mean we've already got the plumbing in to reuse all our waste heat. Now, we're not doing that yet, and we've not done this before. But of course, this is a solved problem in other parts of the world, right? So the Lumi system in Finland from CSC, they're plumbed into their local district heating, and all their waste heat goes and heats local homes and businesses. And we want to do that too. So we've designed the most energy efficient system we can. We run it off completely renewable energy. And then the last thing really is capture the waste heat. Right now we vent it, capture it and actually use it to do something useful. And that's probably about as good as we're going to get, I think.
Yeah, that's great because obviously AI is getting a lot of noise about how much energy it uses and how it's not going to scale.
Yeah.
But I mean, we are seeing large power stations that are literally just big batteries. It makes a lot of sense.
Yeah. We also get asked about water a lot because we're using water for cooling. But most of the system is just a closed loop. So it's the water comes out of the system to the radiators and then just goes back again. When it's really hot, we do start to use some water. We basically wet the outside of the radiators to get some evaporative cooling. But over the course of a whole year, it's something like 1.5 swimming pools worth of water. And that's it. It's about the same as 21 average homes in the UK. So the water usage is virtually zero as well. We do get asked about that a lot. I think there are some big data centers that use lots of water. But fortunately, we don't do that. Although right now, you might not really mind if we used water.
Mm-hmm. Jess?
I guess I'm interested, as someone that runs an operational HPC site, what's the sort of pathway from research to operations? So I guess this is kind of research grade stuff. If it goes down, it's not the end of the world. We'll restart things. So have you thought through that pathway maybe in the future where you've built something on here and now you're pushing that out into the real world and it needs to run with a high SLA? What does that look like for you guys?
Yeah, no, great question. So that's absolutely, this is a research system. So if it goes down, it's annoying, but no one's life depends on it. No one's losing lots of money. Lots of our team comes from backgrounds where they've run operational systems that really had to stay up. So we've got 4 or 5 people from the Met Office in the UK. Sadaf joined us from CSCS, where they used to run the Swiss National Weather Service as well. So all of these things have to stay up. So it's a lot more expensive to do that. You have to really worry about resilience in power and cooling and all sorts of things. You have to have people on site 24/7. Most of what we do is the support's all there during sort of traditional working hours. So we know what it would take to do that. And for the next site, we could do that. We know how much more expensive it would be. And if it's necessary, we'll do it. But if it ends up being more research systems, then we won't have to do that.
I mean, the classic question used to be, how many nines are you offering me?
How many nines, yeah. And how many pounds are you prepared to spend to get it?
Yep, correct. Blair.
Yeah, thank you. Maybe one or two questions related. Have you bought your storage yet?
Yes.
And if not, how many petabytes will it be next year?
Are you selling?
Yeah.
And so Braid looks quite interesting. I'm wondering, so you mentioned there's Kubernetes embedded in the storage there, that's the plan. Is that so that you can, I guess, have many different data services exposed into Isambard AI, depending on the applications and needs and so forth?
Yeah. So any of you involved in buying stuff will probably know we've all just been through a painful experience in that a lot of the hyperscalers are buying up all of the future memories and SSDs and all the things that we need. And that's really pushed the price up, if you can still get what you wanted. So we had exactly that happen to us. We were finalizing this procurement in December. I think if we'd been a couple of weeks earlier, we would have just missed the worst of the volatility, but we were hit straight on by it. So this is a bit less than it was going to be. The amount of money didn't change, but what we've got for it did. I know that affected most people. These things happen in life. I've been around long enough now that I know sometimes you just have to be philosophical about these things. So we were definitely affected by that. But now this is all pretty much turned up. It's all been delivered now. So, so we've actually got it. So if anybody wants to make us a really good offer, for 50 petabytes of SSDs, then see me afterwards. But yeah, so this we've got partners who have big data sets that they currently already store on their own similar systems where they're probably disk-based. And so rather than just replicating their existing capability, we thought, well, let's build something which could actually do something they can't do right now. So one of the main reasons this is solid state, it's not really about density or power, it's really about speed, it's really about performance. And the local Kubernetes cluster is then, we don't know what it will do, but it will probably end up doing all sorts of interesting things. We've got partners who've got, one of them's got a 6 petabyte core, that's their reduced data set, 6 petabytes, and the full one is 30 petabytes. So our 100 gig link would need to run flat out for 2 days per petabyte of that. So that would take 12 days using all our bandwidth to move it. But once we've got it, then we can start doing things which they can't do themselves. And that's before it then gets sucked into Isambard AI and gets processed by thousands of GPUs. So I think this is, we know it'll end up doing lots of interesting things, but we're not quite sure what yet. So all of this should be live in the summer. So by the end of the year, we'll probably start having stories about what it's actually being used for.
All right, so please join me saying thank you to Simon and his new toy.